Next, let's talk about collisions. Suppose we have a frictionless track, some ice or something, and we've got one object sliding. It has a mass m1 and a velocity v1 sliding to the right. And some other mass m2 is initially at rest. When they collide, suppose they stick together. They sort of they couple together and they travel with some new velocity v that we don't know. If the sum of the external forces on the system is 0, and if it's frictionless, then there is no friction. There is normal force and there is gravity, but they add to 0 because they are directed opposite each other and equal in magnitude. So yeah, the momentum, here we are again with momentum conservation. The momentum beforehand needs to equal the momentum after. And I keep writing it as a vector equation. This is a one-dimensional problem, but eventually we could, I mean, you can imagine thinking about 2 dimensions or 3 if you want. But for now, let's just talk about, in the x direction. At the beginning, there is some, well, okay, so how many masses are there in the system? 2. I don't want to talk about m2 on its own. In order to figure out what velocity m2 has after the collision, I need to know what forces m1 exerted on it. But I don't know how I would even measure that. What if we talk about the system? Can we leverage momentum conservation? Before the collision, there are 2 masses. We've got the momentum before one and the momentum before 2. Afterwards, there's really only one combined object. I'm just going to say it's the momentum after of 1 and 2 together. Before the collision, mass 1 is moving to the right with speed v1. Before the collision, m2 is moving not at all. After they are moving as 1 mass, with some new velocity. I'll just say v after. And as long as we know the 3 pieces of information we start with, we can solve for v after. Cool. Honestly, we don't even really need m2 to be at rest. It could have its own velocity. It could be traveling towards v1 and they collide that way. Maybe it's traveling away from v1, but not quite as fast. Maybe m1 is catching up and then they collide and couple together. Okay, so, all right, so it's not 0. M1 V1 plus M2 V2. As long as we know both of these things, now V2 could be positive or negative, depending which way it's going. Well, that's fine. As long as we know all 4 variables, there's only one unknown. So this is great. So we're done, right? What if they don't stick together? I mean, obviously, we've experienced situations where 2 things collide and they don't fuse together and travel as one after they collide. You know, they collide and move off in different directions. You know, I'm thinking about like pool balls, like billiard balls. Thinking about just thinking about cars, right? You know, in a fender bender, right? Like the cars don't fuse together. Well, hopefully. You know, if I throw 2 markers and they collide, they don't stick together, they bounce off each other. Okay, fine. So suppose they don't stick together. And there's actually some final velocity the word before and after are getting, it's a lot to write. Can I switch to initial? V1 sub I for initial, and V2 sub I for initial. Before the collision, this is the story. And then after the collision, there might be some V1 final and V2 final. And they might be going either direction. I don't know. Could be positive, could be negative. The left-hand side is as it was, but the right-hand side is different now. M1 initial, M1 V1 final plus or minus, I suppose, M2 V2 final. Now, we know all the quantities on the left-hand side, suppose they're given to us, which means we know the masses. But now there are 2 unknowns. And at this point, I have no place to go to get a second equation to solve a system in 2 unknowns. I'm completely stuck. It makes me think that I want to have another of these sort of if conditions. If something is true, then I can show that 2 things are equal, and that's my other equation. Then I've got 2 equations, and then I can solve. I just got to figure out what. Next segment.